And now picking up where we left off, you'll notice that I tabbed these guys out here just to make them more readable. They're out in the middle over here. Tabs don't really affect anything. Okay, so now I've started the render function and added the request animation frame, so we'll be able to get an animated rendering function. So now what I want to do is I'm going to go down here. I'm going to tab in. I'm going to now put the 3 position and 3 rotation instruction lines in for the plane that we're going to be working on. So I called it my V plane. That was the name I gave to it. And it is a V plane, which means that it's a video plane. It's a plane with a video on it. Its position .x equals 0. Just putting it in the 0 position. Okay, everything is going to be in the 0 position. So I'm going to just duplicate this stuff this line right here 6 times. Okay, so now what I'm going to do is separate the group here. Now I have to do is change this to a XY, this one to a Z. So now I have the 3 positions as X, Y, Z. I have to change the word position here to rotation because it rotates over X. I'm going to copy this. It rotates over Y. Put the rotation word in first. Over Y and over Z. So that's what we have. We have the 3 rotations. And finally, the last thing I have to put in, now this is important because this is an animation, and this is a video, which means it's live changing. In the first programs we wrote, where we just put JPEGs and pings on planes and surfaces, they don't change. So therefore, you don't have to call in a new frame. You have to call in a new frame for the render. In other words, the render has to get a frame each time it's going to render something new. But in the case of a fixed image, you don't have to call in anything different. You use the same image over and over again. In the case of a video, it's quite different. What you have to do then is you have to actually go to the computer and pull the next video frame up to be in this render frame. So here's how you do that. After you put these 3 guys down, you have to put this line in. It says get new frame. It's one instruction. Get new frame. There it is. And inside here, you put down the name of the video of the object, my plane, my V plane, right here. So it will know what video to pull. It's going to pull the video that's dealing with this V plane right here. So it pulls in that frame. And that's pretty much it. We reached the end of this function. So with this function, I'm sorry, not true. Erase what I just said. We've got part of the render function. Now we have to do the actual part, but we have to deal with the camera. Let's deal with the camera first. First thing I want to do is I'm going to set the color, the background color, in the whole video, on the whole scene. So we say renderer. Don't forget that's renderer, not render. It's renderer dot set clear color, and see where the caps are. That they have to be just where they are. And this is 0, letter X, 1, 2, 3, 4, 5, 6, comma 1. Don't forget what this line does is it simply says we are going to set the background color at that 0x is going to be there. It doesn't mean anything to us in what we're doing. But these 6 zeros do, because they're replaced with a hexadecimal number. You know, remember, like whatever the HTML color is, you just put it right in here. It's got 6 characters to it. Comma 1, 1 is opacity, which means it's going to be opaque. You're going to be able to see it. Put a 0 in here, you wouldn't see the background color. So now is that 1 right that determines whether or not you see the background color. So next thing I want to do is I want to start dealing with the camera. The camera has 2 coordinates we're interested in. The y coordinate's always 0. We're not going to move it during these programs, these early programs. So all we're concerned about is the flat plane we're standing on, which is x in one direction and z in the other. So if we go left or right, we're going X in an X direction. If we go forward or backwards, we're going in the Z direction. Okay, so what I want to do is I want to tell the camera where it is standing, where in the X and Z. What is its X and Z coordinates? Where is it? Now it assumes Y is 0, but we have to set. It would assume they're all 0 unless we set them. So we're going to set the X and the Z position so we'll know where the camera is in the scene. And the way you do that is you say camera position dot position dot X. We're saying where is the X of the camera. And I'll bring this up a little bit here. And so we say we have to use this special function that's built into this program. It's called xBounce. You don't have to worry about what it does. But what you feed that program, what you have to put in there, is the camera's radius, which is the variable we created above. The camera radius and, comma, the number of degrees that the camera has turned. In other words, in order to find out where the X position of the camera is, it looks to see how long the radius is, what's the distance between the camera and the center of the scene, and it takes the number of degrees that the camera has gone around the scene, plugs that into a formula, and comes back with where are we in the X position. Okay? And there's another function that tells you where you are in the Z position using pretty much the same information. So you say camera dot position dot Z, and this is always done the same way. You don't have to worry about it. You just follow the rules. Y bounce camera radius, comma, degrees. There it is. So those two lines, those three lines right there, have set up everything. This is the last camera line, which says camera dot look at. That's a special function that says scene dot position. What it does is, that's a dot right there. That's a period right there. Scene dot position, all lowercase. What that says is, wherever the camera is, have it look at the middle. Have it look at 0, 0, 0, right in the middle of the scene. So it'll always look that way. No matter where you move the camera around the field, X and Z, it'll always look towards the middle. So that's built in. So these three lines right here pretty much go with the territory. This one, as you move the camera left and right or forward, backwards, this thing here, based on these two functions, will tell you where camera X and Z is, and then the camera will always look at the center of the scene. So those guys take care of themselves. They're all kind of automatic. But don't forget, you have to have up above here, in the key hit function, you have to tell degrees what to be, so it'll know how many degrees it is down here. And you have to tell what the camera radius is, because you're moving that in and out. And you tell that to this function also. So those two pieces of information determine where the X and where the Z are, and that's what the camera has to know. Okay? Then, final step in this thing is to actually make it render. So we say renderer dot render, dot set size, size. This is where you set how big the screen is going to be. If you just put frame width, comma, frame height, what that'll do is that'll make it the size of your screen. In other words, the image of 3D world will be as big as your screen width and height. If you divide this by 2 and divide this by 2, then it will be it'll be a quarter of the size of the regular screen, half in each direction. Okay? And here it is, the magic line which does everything. You say renderer dot render. This is when it actually renders the scene. Scene, comma, camera. There it is. That's the end of the function. So if you look at this render function, it's got three major parts. It's got putting your objects into position. It's got putting the camera into position. And then finally it says, draw the picture. Make the scene draw. And that's it. So therefore, the render function's finished. And we're also /script. We're at the end of the JavaScript, and we're at the end of the head. And now we're in the body. I'm not going to do anything. I'm not going to center or anything because the picture takes up the entire screen, so it doesn't make any difference. So now what we have to do is, first thing we have to do is bring in the code, which is called graphics.xx. Graphics.xx is what contains all of the behind-the-scenes stuff that you really don't want to deal with. Okay, so you say script. Don't close it, leave it open. You say source equals quote http://works.com/graphics xx. Be sure to put the xx in there, .js, unquote. Close that script and open the new one, / like that. There we go. That's it. That's what it looks like. I'm gonna tab it over here. And there it is. That's what it looks like. That's an important instruction. Make sure that's exactly written exactly the way it is. And now, let's bring in the plane. Let's bring in the plane. Tab script. And we say variable. And I'm going to give the name my v plane. That's the name I gave it up above, so I have to give it the same plane right here. In. I have to give it the very same name as it is up here. Okay. Equals new. And this has to be exactly like this. Make v plane. That's a function, special function. And you say, okay, I want my image to be, say, my rectangle to be 240 by 240. That's its dimensions. And I want it to have an image on it that's, see, what will that image be? We don't know yet. I'm going to, I'll put an image in there in a second. I'll just leave it empty for now. I'll put image in there. .mp4, and we'll go get an image. And finally, I say, okay, that takes care of that. Semicolon /script. This program is basically over. So we say /body /html. Program's done. I'm going to save it on the desktop. And I'm going to call it, let's call it plane 1. Plane 1.html. And I'm going to make sure that it has all files. Say save. So it's going to be on my desktop here. Plane 1. Okay. Now, before I can run it, I have to get a video to go into it. So let me see what I've got here. I'm going to look around for videos, see if I can find one. I'm sure I have some right here in mind. Let me see what I've got. Videos. Acrophobia. Oh, that looks scary. Alaska Fire. I'm going to pull that one right there. Say copy. And I'll bring it out to my desktop. So I'm using, it's called Alaska Fire MP4. Okay, so I've got this thing on my desktop and I call it Alaska Fire right here. There it is. That's the video. It's going to be on the screen 240 by 240. Now I'm going to save this again. Now it's on my desktop, and I'm going to take that it's called plane 1. I'm going to drag it to Google Chrome and see what happens. Try it one more time here. Sometimes it flips out. Okay, close this. One more time here. Drag it to Chrome. See what happens. There it is. There's the fire going. I can use my arrows, my forward arrow. I can go in towards the fire. I can move my backwards arrow, the lower arrow, and go away from the fire. Or I can go left and circle around the fire, which is because it's on a plane, it's going to look like the plane is spinning. But really what we're doing, the left, now I can go to the right. What we're really doing is we're just going around the image. Okay? And that's it. There you go. That's how you make a plane with a video on it. Let me quickly review it just to be sure that you have all the parts and you understand why it works the way it does. To begin with, to get the video in onto the plane, what you do is you use this line right here, and that exact line, except give it whatever name you want to your plane. You say new, make V-plane, make the dimensions whatever you want the dimensions to be. Mine's square, 240 by 240. And then you put in quote marks, it can be single or double, doesn't make any difference. Put the name of your video .mp4. Make sure it's an MP4 file. And then close that. That means now that you have the video in there, now what you have to do is go up here into the render function, and you have to set its X position, Y, and Z positions. And you have to determine its rotation in the X, the Y, and the Z direction. Now, I'm going to show you something here. If you wanted, supposing you wanted this image to be a little bit to the right. So see that position right there? That would be in the X direction, a little bit to the right. Supposing I just put plus 50 in there. Sorry, I don't have to put plus. I can just put 50. It assumes it's plus already. So if I just put 50 right there, what will happen is, when the program starts, the image won't be in the middle anymore. It'll be a little bit to the right, because that tells me where the initial position of it's going to be. I save that, and let's run it again. See, it's a little bit to the right this time. It was in the middle before. Now it's to the right. I can move a little bit more to the right. Let's do that. What if I move it 100? Like this. Then I run it again. Now you can see it's even more to the right. I can move it up. For example, supposing I just leave it in the middle, in the X direction, but I move it in the Y direction by 100. Let's put 100 here. Save the program. You got to save it every time you do that. Hit this. There it is. You see, it's up. It's gone up the screen, and that's how it works. That's how you position. That's how you position images using these position numbers right here. That tells you where your object is. Another thing you can do down here, you can rotate by a certain amount. Now, you got to remember the rotation doesn't work in degrees. It automatically works in what they call radians. Now, we're using degrees down here when we rotate our camera, but that's because I have a special program that does that for us. If you just put, maybe just put 1 degree right here, for example. If I put 1 degree, it wouldn't give you 1 degree. It would give you a radian, and we don't want that because radians are too big. I'm going to show you what happens. Supposing I say this. Supposing I say plus equals 1, semicolon. Now what that would do, as you can see, every time the program would come to this point, it would add 1 to the rotation of y. So in other words, it would add 1, but it's adding 1 radian. So therefore, that's like a 1/6 of a circle. And so it's going to jump a 1/6 of a circle every time this thing comes to a frame. Watch what happens when I run this program. Let's save it. Let me run the thing now. See how fast it spins? It's spinning fast because it's making big leaps. That 1 is too big. So here's what you do. You don't have to know radians to do this. You say, okay, if a radian is 1 and it's a great big chunk of a circle, then just put a 0.00 in front of it. And now what you've done is you've made it small. So in other words, it's only going to add this little bit to the rotation every time. And that's just part of a radian, and it will look better. You save that, and watch what happens. Watch how fast it spins. You see it's spinning, but it's spinning very, very slowly. That's because 0.001 is being added to it every time, and that's a very slow turn, you see? Now, that kind of a turn with the plus sign right there is different than the previous one. If I didn't put that plus sign right there, what would happen is when the program opened, it would open and the Y would be at that angle all the time. But you wouldn't even notice it because it's so tiny you wouldn't even notice it. If I put a 1 here, let's put a 1 here. Now you will notice it. In other words, 1 is a big part of a circle, so it's going to be like a 1/6 of a circle angled towards you. Watch what happens. Save. Run the thing. And there it is. Notice what the angle it's at right. Instead of flat, it's actually turned quite a bit. But it stays in that position. Now I can press my arrows. I think I can press my arrows. I don't seem to be able to get my arrows to do anything. I think I did something wrong with my arrows here. What did I do? Let me just check it out, see what's wrong. See why it won't do this. Let's see. Degrees, 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 37, 39, 40, 38. My V-plane rotation in the Y is 1. That's interesting. Let me just run this again and see what happens. Maybe I didn't save it. Let's save it. Make sure I save it. They are here. Yes, it's fine. And the arrows do work. I just didn't save it, I guess. So there you have it. It starts off, it stays whatever angle it's at. But what I'm doing with the arrows, I'm just moving around the screen. It's still at some angle, it's just that we're going in a different place. That's the only difference. So there you have it. That's how you actually create a plane and make it work. Now what I want to do is I want to show you what the change would be if you change this into a sphere with a movie on it. That's a little bit different. A sphere with a movie works the same way, except that instead of projecting the movie onto a flat plane, you're projecting it onto a sphere, which looks peculiar, doesn't look the same, stretches it and everything. But the nice thing about a sphere as opposed to a plane is that you can actually go into a sphere while a movie's playing, so you can go inside of it. And that's what makes it interesting. So let me change the things that are necessary to make it show you a sphere. To begin with, when you first make the object down below, down here, you can't use my plane, make V-plane, because we're not making a V-plane anymore. What we're going to do now is we're going to make a video for a sphere. So we have to create that spherical surface, and we have to put the video on it. So let me show you what that looks like. This is all going to be changed. From here to here has to be changed. First thing you say, I'll get this out of the way. First thing you say is variable. You give it a name. And I'm going to call it my sphere, space my sphere equals new space video sphere is the function. Video sphere. That's what you have to use. That's the expression you have to use. And then you have to say, what's the diameter of the sphere? I'm giving it 100. And then you have to say about its ribs. It's got 32 by 32 ribs, which you can change anything you want. And the ratio of the movie is always 4 in the x direction, 3 in the y direction. It's 4 to 3. That's always use that, comma. And now we have to put down Alaska file. Let's go fire.mp4. Don't forget, you can use double or single quotes. It won't make any difference around that thing. Go like so, or a semicolon, and there it is. That's the creation of the sphere. So now, instead of having a plane, you're going to have a sphere with that movie on it. But if I change the name of everything down here, I have to change stuff up in here. No, I don't have a plane anymore. So what I have now is I've changed the name. I've changed it to my sphere. So I have to change the name of the object to my sphere. Right here, I have to say my sphere right here. So I have to change all these 7 things all the way down here. Change that one. I'm going to just copy and paste. Copy over that one. Whoops. Copy over that one. Copy over this one. Always got to be careful when you do this stuff because you could cause a lot more problems than you know. Once you've copied something incorrectly, there's a mistake somewhere and you don't want to make that mistake. Okay, so I've changed my sphere, all my sphere, but the thing right here that says V-plane, it should say V-ball for a sphere. That's the magic word, is ball right here. This comes with the territory. You have to always call it that. All spheres are called, with videos on them, are called V-ball. Okay, so change this one here, all 6 of them. I say you got to be pretty careful. There it is. It's all to change the ball. My sphere is everywhere. My sphere is in here. And this is the new name of it right here. And everything else is the same. Nothing else has to change. So I say save. Then I run this program, see what it looks like. There it is. The fire, let me go around it. So I'm I'm looking around. The fire is right here. If I want to go in and see the fire, I go forward right into the fire. Now this is where it gets interesting, because when you go into a sphere, you're inside of it. And everything around you is on fire. As I roll around now, looking around, everything's on fire. Because the flame is all around me now. It's except that line right there. So the reason why the line is there is because the left and the right side of the movie frame don't exactly match. So it puts a line in the thing. There's ways around that, but we have to, that'll come at a later date. But there you go. There you go. If you come out of it, you look at the fire, the flames from the outside. And that's the difference. See? So there you go. That's how you do it. If you want that sphere to just be rotating, let's do that for fun. Suppose I want that sphere just to rotate slowly. I go to the rotation, the Y rotation right here. Oh, we left it at 1. It was rotating very, very slowly. We did that. Actually, was that rotating or wasn't it? It should have been rotating. I think it was. Let's run this again. I want to take a look at that. Why isn't it looking like it's rotating? That's interesting. Let's take a look here to see if we got something wrong. My sphere V-ball rotation equals Y equals 1. Let's make the stitch to see what happens. Oh, well, that's fine. Yes, it did rotate. It rotated one time. It didn't keep rotating. It just rotated to one position, stayed there, because there's no plus in here. So therefore, what happened is it was at an angle to us, but we never noticed why. If I take this one out of here, you'll see the difference. Watch what happens when I run it now. You'll see it in a different position than it was previously. See, now it's in a different position. Let me put the one back and you'll see what happens. It turns the thing a little bit, but it stays in that position. It just turns a little bit and stays in that position. Do it again. See, now it's in this position, which is different than the previous one. The previous one was over here. It was right in this position here. It's quite different. So, now what I want to do is, let's make the thing rotate around. So what you do is you say, okay, plus equals 0.01. I'm just making it small because if I make it 1, it's going to be too big. As I said, this is radian, so we're going to use 100th of a radian. Let's see what happens. See, it rotates. And it rotates kind of at a reasonable speed. And there you go. If you're going to make a planet or something, you do the same thing. You rotate it like that. And that's pretty much it. Okay. So now we have it for a sphere and for a plane. Let me now show you what it looks like when you do a torus, which is a donut. We'll do the donut. Okay. I'm looking. See for a second here. I'm looking this stuff up. Cylinder. Oh, let's do a cylinder first. We haven't done a cylinder, so we'll do a cylinder first. To do a cylinder, you go down to the bottom and you change the thing to a cylinder. This is a sphere. This is a video. We don't want that. What we want is to do it as a cylinder. So to do it as a cylinder, what you do is you change the code here, down here, that says, make me a cylinder. I'm going to call it my tube. I'll just give it the name my tube right here. And it's the same. It says new is correct, but this has to change right here to V cylinder. That's a video cylinder. It's like this. V cylinder. Okay? And then it's a cylinder now, so therefore it's got a top and a bottom. The top has a radius, the bottom has a radius. Like a drum, it has radius at both ends. I'm going to give this one a 50 radius on top. Let me get rid of these numbers here. I'm going to give it a 50 radius on top and a 50 radius on the bottom. And I'm going to make it 100 units tall. Like that. I'm going to tell it to be 32, 32, which means it's how many ribs it has and round it. And 4 to 3 is the video ratio. 4 to 3. Don't forget, it's 4 wide and 3 tall. And I'm going to use the same Alaska Fire image on it. Only this is going to be a cylinder. That's the cylinder information right here. Top radius, the bottom radius. By the way, if you want to make a cone, all you have to do is make one of these radiuses 0, and it will turn it into a cone. Well, why don't I do that later, and we'll actually show you how to do it. And there it is. So that's pretty much the parameters you need. Okay? Now, up in here, you have to make a change. I called it my tube, so I'm going to change that to tube right here. My tube. And I have to call it V-tube. Call it V-tube this time. Right here, tube. So I have to change all these guys to V-tube all the way down. This one. This one. This one. This one. And I have to change all these guys to my tube. So my sphere's got to go. My sphere's got to go. My sphere. My sphere. My sphere. And I have to change this one here too, because it's a different video. That should do it. Save this thing and see what happens. There it is. And also it's turning, by the way, because I left those numbers in there, the turning numbers. But that's the cylinder right there. Let me get rid of the turning numbers and we'll go into the cylinder. This turning number is right, still going on. See, so I'm turning over the y-axis. Let's make it, keep it at 0 for now, and then we'll run it like that and see what happens. Let's go for a trip into the cylinder. Okay, here's the cylinder. It's got the fire on it, so it's good for a trip in. Here we go. We're going in. Put your fire hat on. There we are. We're in the burning flames. If you turn around, you see the burning flames all around us. We are in the fire. And that's pretty much it for the cylinder. That's how it works. Okay? There you go. Now the final thing I want to show you is the torus. The torus is a donut. And the only thing about the torus that's different is that when it puts the texture on, it's kind of awkward looking because it doesn't actually put the texture in any smooth way. It's pretty rough on how it puts the texture. It lays a little piece here, a little piece there, and the thing doesn't quite look like anything good. So what I want to do is I want to show you that. Find a thing here. Video. 1 second. Okay, here it is. Step number 1, you have to change the kind of object you have down at the bottom here. So we have to get rid of this and change it. I'm going to keep the name MyTube. I'll save a little bit of time. We'll leave it as MyTube. That's because that's my name. You can name it anything you want. But I have to change all these things over here. This thing changes. It's not V-cylinder anymore. Now it's Video Torus. V-I-D-E-O Torus. And then I'm going to give it the large radius. That's the one around the entire donut. Is 100. And then I'm going to use 50 for the radius of the cylinder that is the donut. Okay, that's the small radius they call it. And then I'm going to give it a 32, 32. Got that 32, 32, and then a 4 to 3, and those are all the same. This is exactly the same as the previous one at this point. Now I have to go above here. I kept my tube, but now what I have to do is I have to change the V tube, which is the general kind of thing object it is. It's no longer a cylinder. Now it's a torus. So I call it V donut. That's the word I give it. That's all of them have to be called that. All toruses. V donut. So I'm going to take this, copy it, put it here, 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 here. There it is. This is ready to go. Run it. See what happens. There it is. Torus with the fire on it. You can rotate, look around it, go around the sides of it to look at it. But you can see the way the texture lays on it. It doesn't lay very well. And essentially what I always tell people is, in the case of a torus, if you want to put texture on it, find something that doesn't have edges to it. Like, for example, just one great big bunch of stones. And so when it goes up against the other end of it, it'll look okay. Let's take a trip into the torus. I'm going to go forward into it. There you go. Turn a little bit. Go right into it. There it is right there. That's the torus. It's pretty weird, doesn't it? Flames and everything going. It's kind of hard to describe. Let's go over here and do it a little bit better, I think. That's a little clearer. You see what it's like. It looks kind of strange, doesn't it? So there you go. That's the torus. Tutta finita. This class is over.